Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
Jupiter is terrifying, and we still don't fully understand it. At first glance, Jupiter looks almost unreal. From far away, it doesn't look dangerous at all. It looks beautiful. Huge bands of orange, cream, and brown wrap around the planet like someone edited the perfect space photo. The clouds look soft, calm, almost inviting. And that's the trap. The universe has a bad habit of making deadly things look pretty. You stare at Jupiter long enough, and something starts to feel wrong, not because it moves, because it's too big to understand. There's no clear scale, no horizon, no reference point. Then you notice something else. You feel pulled. Very slightly, but it's there. That's Jupiter's gravity reaching out from millions of miles away. And if you get closer, this stops being a peaceful space tour and becomes physics taking control. Because Jupiter isn't just big. It's absurd. Over 1,300 Earths could fit inside it, and its mass is 318 times greater than Earth's. If it were hollow, you could practically lose planets inside it. But the scary part isn't the size. It's what Jupiter actually is. Mostly hydrogen and helium, the same ingredients that make stars. That's why scientists sometimes call it a failed star. Stars are born when gravity crushes gas hard enough to ignite nuclear fusion. Hydrogen turns into helium, energy explodes outward, and a star lights up. Jupiter almost made it. Almost. But in space, almost means a lot. It would need about 13 times more mass to truly ignite. Clothes only counts in horseshoes and hand grenades. So now Jupiter sits in a strange middle ground, too massive to feel like a normal planet, too small to become a star. A cosmic runner-up. What makes it even stranger is that Jupiter still gives off heat from deep inside itself, more heat than it receives from the sun. It's still slowly shrinking, still trying to become something greater. But it never will. It formed too far from the sun, in the cold outer regions of the young solar system. There was enough material but not enough pressure, not enough time, and not enough luck. And that changes the way you look at it. Those soft clouds stop looking peaceful. They start looking heavy, violent, crushing. The beauty is still there. But now you realize the danger was always there too. We already talked about how Jupiter is basically a star that almost made it. But the deeper you look, the stranger it gets. Because Jupiter doesn't really feel like a planet. It feels more like a half-finished version of a solar system. First, the numbers are insane. Jupiter has 318 times Earth's mass. Not a bit bigger. We're talking about a world so huge you could fit over 1,000 Earths inside it. And it's made mostly of hydrogen and helium, the exact same stuff stars are made of. So why didn't it become a second sun? Simple answer, it wasn't heavy enough. Stars are born when gravity crushes gas so hard that the core reaches millions of degrees. Then nuclear fusion starts, and the star lights up. Jupiter got close. Very close. But in cosmic terms, close still means missing the target by a mile. It would need about 13 times more mass to ignite. Close, but no cigar. So now it sits in this awkward middle ground, a giant gas world that almost became something far more powerful. But here's where things get really weird. People think planets should have a surface, somewhere to land, walk around, plant a flag. Jupiter doesn't work like that. There's no solid ground. No crust. No clear boundary. No moment where you can say, okay, now I've landed. If you fell into Jupiter, you'd pass through those beautiful clouds first. They look soft from space, but they're actually violent storms of hydrogen and helium. The deeper you go, the worse it gets. Pressure rises so much that the gas turns into liquid hydrogen. You're no longer flying, you're being crushed downward. And deeper still, physics starts acting like science fiction. Hydrogen transforms into something called metallic hydrogen, a bizarre state where it behaves like an electrical metal. Scientists think this layer powers Jupiter's massive magnetic field. And that magnetic field is monstrous. If Earth's magnetic field is a desk fan, Jupiter's is an industrial turbine. But the creepiest part? You never reach a bottom. No solid floor. No clean ending, just more pressure, more heat, and stranger forms of matter. Falling into Jupiter isn't like hitting the ground. It's more like slowly becoming part of the planet itself. Like an elevator with no bottom floor and no emergency stop button. Scientists even joke that you wouldn't crash into Jupiter. You'd be crushed into plasma long before that happened. And honestly, that raises a terrifying question. At what point do you stop being you? In the clouds, in the liquid hydrogen, or the moment your atoms lose their structure completely? Nobody knows. When you get close to Jupiter, you realize something strange. This isn't weather. This is the planet's permanent condition. On Earth, weather comes and goes, a rain today, sunshine tomorrow, maybe a rainbow if you're lucky. But Jupiter doesn't really do clear skies. The whole planet is covered in giant colored bands, bright zones where gas rises, dark zones where gas sinks. It's basically an entire world constantly boiling and rolling over itself. And the winds are insane. Near the equator, they can blast past 300 miles per hour. That's not stormy weather. That's your airplane is now a kite territory. But somehow, all this chaos doesn't tear the planet apart. The reason is something from physics class most people forgot about: the Coriolis effect. Jupiter spins ridiculously fast. One day there lasts only about 10 hours. That rapid rotation stretches the atmosphere into those long striped bands. So instead of random chaos, you get organized chaos. A planet-wide storm system with structure. And unlike Earth, there's no land or ocean to slow things down. No surface friction. No reset button. The storms don't end. They just change shape and keep going. That means weather forecasts on Jupiter would sound pretty useless. Not sunny tomorrow. More like tomorrow's storm is the same storm as today, just wearing a different face. And hidden inside those giant cloud bands is the most famous storm in the solar system: Great Red Spot. Humans first recorded it back in the 1600s. While people on Earth were still sailing wooden ships and arguing about whether the Earth orbited the Sun, this storm was already spinning on Jupiter. At one point, it was large enough to fit several Earths inside it. And it's still going. That's the creepy part. Storms on Earth die out in days or weeks. This one has survived for centuries. Like a computer program stuck running forever at 100% CPU. Scientists know it's shrinking, but nobody fully understands why it's lasted this long in the first place. By all logic, it should have fallen apart ages ago. But it didn't. And that creates a bizarre comparison. Human civilization went from sailing ships to rockets, from candles to the internet, while Jupiter's giant storm barely changed at all. Just spinning quietly above the clouds like an ancient machine. But now it is changing, is shrinking, tightening, slowly fading. And that raises an unsettling question. If the Great Red Spot finally disappears one day, what happens next? Does Jupiter calm down? Or does the planet create something even worse? Nobody knows. Because on Jupiter, the most stable thing is a storm that never truly stops changing. Just when you think Jupiter has already maxed out the word extreme, it casually reveals another level. Its magnetic field. Earth's magnetic field is basically a shield. It protects us from solar radiation and keeps our atmosphere from being stripped away. Jupiter's magnetic field? That thing is less shield and more cosmic particle prison. It's over 20,000 times stronger than Earth's. Not sci-fi movie strong, beyond sci-fi movie strong. Its magnetic bubble stretches millions of miles into space, trapping high-energy particles from the sun and from volcanic material blasted out by nearby moons. The result is a radiation zone so brutal that a human wouldn't slowly get sick. You'd get cooked electronically almost immediately. That's why Juno had to fly through Jupiter's system like someone sprinting through a burning building. Engineers literally wrapped its most important instruments inside a thick titanium radiation vault. Basically, go in fast, grab data, and get out before space itself deletes your hardware. But Jupiter gets even stranger when you look at its moons. Earth has one moon. Jupiter has an entire family reunion happening out there, more than 90 known moons. And 4 of them completely changed astronomy forever. The Galilean moons, first observed by Galileo Galilei in the 1600s. Because for the first time, humans saw something shocking. Not everything revolves around Earth. Around Jupiter was a miniature solar system of its own. First there's Io, a volcanic nightmare constantly erupting with lava and sulfur. Jupiter's gravity squeezes it so hard that its interior heats up like a stress ball from hell. Then there's Europa, an icy world hiding what may be a massive liquid ocean beneath its frozen shell. And where there's water, there's always the question, could there be life? Next comes Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. It even has its own magnetic field, which is honestly showing off a little. And finally Callisto, an ancient crater-covered world that looks frozen in time, like it stopped updating billions of years ago. That's what makes Jupiter feel less like a single planet and more like an entire system. One world surrounded by volcanic chaos, hidden oceans, radiation storms, frozen relics, and tidal forces all interacting at once. A mini solar system running inside the real solar system. And here's the strange part. In Jupiter's neighborhood, danger and possibility usually come together. The same radiation and tidal forces that create hellish environments may also help create places where life could survive. Every rose has its thorn. Before 1610, the universe felt simple, comfortable, even. The Earth sat at the center, the moon circled us, the sun lit the sky, and the stars decorated the night like cosmic wallpaper. Humanity thought it had front row seats to creation. Then Galileo Galilei pointed a telescope at Jupiter and accidentally ruined the whole story. He noticed 4 tiny lights moving around Jupiter night after night. Those lights became known as the Galilean moons. And with that one observation, humanity learned something deeply uncomfortable. Not everything revolves around Earth. That single moment cracked the old Earth-centered model wide open. Because if moons could orbit Jupiter, then maybe the universe wasn't designed around us at all. The telescope didn't argue. It didn't debate philosophy. It simply showed the evidence and quietly said, "You've been looking at this wrong." That may have been the first real cosmic ego check in human history. Suddenly, Earth wasn't the center anymore. Humanity wasn't the main character. We became observers instead. And Jupiter stopped being just another planet. It became a system of its own. But here's the funny part. More than 400 years later, Jupiter is still confusing us. Sure, we've sent probes. We've photographed its storms, mapped its magnetic field, studied its atmosphere. Pioneer 10 flew past, Voyager 1 gave us stunning images, Galileo orbited the planet for years, and Juno still dives through its radiation-filled environment today. But the closer we look, the stranger Jupiter becomes. We still don't fully understand what's inside it. Does it even have a solid core? Why does its magnetic field behave the way it does? How has the Great Red Spot survived for centuries? And the deeper mystery is this. We can approach Jupiter, but we can never truly enter it. Its radiation belts are deadly. Its atmosphere becomes crushing beyond imagination. And because it's a gas giant, there's no surface to land on in the first place. The deeper you go, the more alien the physics becomes. Scientists sometimes joke that studying Jupiter is like studying a hurricane while never being allowed to touch the ocean beneath it. So modern exploration has turned into a careful balancing act. Fly close, collect data, escape radiation, repeat. But over time, another realization appears. The more we learn about Jupiter, the less it feels like a normal planet. It feels more like a gigantic living system, dynamic, layered, constantly changing. Not just a world, a machine. And that changes the question completely. It's no longer, can we get close to Jupiter? It's, if we truly did, would we still call it a planet? The more you study Jupiter, the stranger it becomes. Because Jupiter isn't just a giant planet. It behaves more like a system-level force inside the solar system. For years, people called it Earth's protector. And honestly, that's partly true. Back in the early solar system, space was chaotic: rocks, comets, and debris flying everywhere. Many of those objects headed toward the inner solar system. Then they encountered Jupiter. And Jupiter's gravity changes everything. Some comets get thrown completely out of the solar system. Some asteroids get captured. Others get redirected onto entirely new paths. It's like a cosmic traffic controller with unlimited authority. That's why Jupiter is sometimes called the solar system's vacuum cleaner. Sounds heroic, right? A giant security guard standing far away, taking the hits for Earth. But here's the catch. Jupiter doesn't just remove danger. Sometimes it creates it. Gravity doesn't work with good intentions. It just moves energy around. While Jupiter can deflect dangerous objects away from Earth, it can also fling new ones inward. In other words, it's both shield and slingshot. Like a system admin who occasionally hits the wrong button. So scientists eventually realized something important. Jupiter isn't good or bad. It's just physics. No purpose. No plan, just gravity doing what gravity does. And that leads to a fascinating question. What would the solar system look like without Jupiter? Some simulations suggest Earth could face more asteroid impacts. Others suggest certain dangerous objects might never get redirected toward us in the first place. So Jupiter may reduce risk, or simply redistribute it. That's a big difference. But zoom out even farther, and the story gets even wilder. Because in the grand scale of the universe, Jupiter may not be special at all. Astronomers have discovered huge numbers of gas giants orbiting distant stars. Some are even more extreme, so-called hot Jupiters. These worlds are similar in size to Jupiter but orbit incredibly close to their stars, completing an orbit in just days. Their atmospheres are blasted by radiation and heated to terrifying temperatures. Basically, Jupiter in a cosmic oven. And here's the real surprise. Planets like Jupiter seem to be common across the galaxy. Thanks to missions like Kepler Space Telescope, we now know our solar system may not be some perfect cosmic blueprint. It might just be one version among billions. Which means Jupiter isn't necessarily a unique masterpiece. It could simply be one of the universe's favorite designs, mass-produced on a cosmic assembly line. And maybe that's the strangest realization of all. For centuries, humanity treated the solar system like the standard model of how worlds should look. But space doesn't do standard answers. It does possibilities. Imagine waking up tomorrow and Jupiter is just gone. No explosion. No collapse. No Hollywood-style disaster. Just erased from the universe like someone hit delete. Sounds like science fiction, but physicists can actually think this through seriously. And the scary part is this. The first thing that changes wouldn't be the sky. It would be gravity. Jupiter has always been the heavyweight of the solar system, over 300 times the mass of Earth. Sitting between the inner planets in deep space, it acts like a giant gravitational traffic hub. Remove it, and the solar system doesn't instantly fall apart. But the balance starts to shift. The asteroid belt would likely become more chaotic. Objects that were once nudged into stable paths could begin drifting into new orbits. Some collision risks might increase, others might decrease. It's less like pulling the plug on the solar system, and more like removing the biggest traffic light in a crowded city. And Earth. We wouldn't suddenly fly into the sun or get launched into deep space. The changes would be subtle. Tiny orbital shifts. Long-term climate variations over thousands of years, small changes slowly stacking up over time. And that's the unsettling part. There'd be no warning sound. No shaking ground. No giant cosmic alarm. Physics doesn't care about drama. It just changes the numbers and keeps moving. Still waters run deep. And maybe that's when you realize something strange. Part of the reason the solar system feels stable is because Jupiter has quietly been shaping it this whole time. Not as a guardian. Not as a hero. Just as gravity doing what gravity does. But then another question appears. We talk about Jupiter's storms, radiation, magnetic field, and moons like we understand it. But do we really? Everything we know comes from pieces, telescope images, probe data, computer models, gravity measurements. We stitch those pieces together into a version of Jupiter our brains can understand. But that doesn't mean we've seen the whole thing. We know its clouds, but not its deepest layers. We think there's metallic hydrogen inside, but we've never directly seen it. Even Juno can only skim past the planet briefly before escaping the worst radiation zones. We're always studying Jupiter from the edge, never from the center. So Jupiter stops feeling like a planet you can fully figure out. It starts feeling more like a gigantic machine that can never be opened, only observed from the outside. And maybe that's the bigger lesson. Understanding the universe doesn't always mean seeing the whole truth. Sometimes it just means building the best explanation we can, from the small corner we're allowed to see.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.